Let us take a look at a select example. Select u.id as user underscore ID. Max o.order underscore date as latest underscore order underscore date. Count p.product underscore name as electronics underscore orders. From users as u. Join orders as o on u.id equals o.user underscore ID. Join products as p on o.product underscore ID equals p.id. Where u.country equals USA. And p.category equals electronics. And o.order underscore date between 2023-01-01 and 2023-1231. Group by u.id. Having count p.product underscore name greater than 2. Order by latest underscore order underscore date descending. Limit 10. This query retrieves data from multiple tables. We begin by selecting the user ID. Next we select the most recent order underscore date from the orders table for each user. Then we count the number of rows that have a non-null product underscore name for each user. The data is pulled from 3 tables: users, orders, and products. The joins specify the relationships between these tables, linking user ID to orders, and product ID to orders. The where clause filters the data to only include orders made by users in the USA, orders for electronics, and those placed within 2023. Group by u.id groups all the filtered rows by user ID, each group represents one user, and the aggregate functions, max and count, are calculated per group. Having count, p.product underscore name, greater than 2 filters the grouped results, keeping only the groups, users, where the count of electronics orders, count, p.product underscore name, is greater than 2. It ensures you only see users who ordered electronics more than twice in 2023. Having works on groups, unlike where, which works on individual rows. Order by latest underscore order underscore date descending sorts the final results by the latest underscore order underscore date column in descending order, newest to oldest. Users with more recent electronics orders appear first. Limit 10 restricts the output to the first 10 rows after sorting. We get the top 10 users with the most recent electronics orders who meet the having condition. Let us take a closer look at each part of this query. Select u.id as user underscore ID. Max o.order underscore date as latest underscore order underscore date. Count p.product underscore name as electronics underscore orders. Select. This line picks out the ID column from the users table and gives it a friendly label, user underscore ID, in the final result. Since we are grouping by this later, it is the anchor that ties everything to a specific person. Max, here, we are digging into the orders table to find the order underscore date column, which tells us when each order happened. The max part is like flipping through a user's stack of order receipts and pulling out the one with the most recent date. We then slap the label latest underscore order underscore date on it, so the result shows the last time this user bought something in our filtered set, electronics in 2023, in this case. Count, this line looks at the product underscore name column from the products table, which lists what was bought in each order. The count function is like tallying up how many times a product name shows up for a user, essentially counting their orders. Since we have filtered to only electronics elsewhere, this becomes a count of how many electronics items they purchased. We name it electronics underscore orders in the output, making it clear it is the total number of electronics buys per user. In short, we ask, give me each customer ID, user underscore ID. The date of their latest purchase, latest underscore order underscore date. And how many electronics they bought, electronics underscore orders, over the year. Column aliases, like, max, o.order_date, as latest_order_date. When you write something like max, o.order_date, it is functional but not exactly self-explanatory in the output. Adding as latest_order_date is like giving your result a name tag. It tells anyone looking at the data, hey, this is the most recent order date. Without it, you would get a generic column header like max, o.order_date, which is a mouthful and not very human-friendly. You can get creative. You could call it most_recent_purchase or last_order instead, whatever fits your vibe. SQL does not care, as long as it is clear in the result set. With functions like max, count, or sum, aliases are almost a must. The raw function name as a column header looks clunky in reports or apps, and aliases smooth that out. Table aliases, from users as you. Users as you is like giving the users table a nickname. Instead of typing users.id or users.country everywhere, you just use u.id or u.country. It is a time saver, especially in queries with long table names or multiple joins. Imagine typing customer_order_history without an alias. In our query with users, orders, and products, aliases, u, o, p, keep the joins readable. Without them, you have users.id equals orders.user_id and orders.product_id equals products.id, which gets wordy fast. Aliases make it snappy. u.id equals o.user_id and o.product_id equals p.id. There is a subtle art to picking aliases. U for users is intuitive, but you could use USR or even people if you are feeling for it. Some people match initials, like O for orders, others go wild and use X for no reason. In most SQL flavors like Postgres, MySQL, SQL Server, as, is optional for both column and table aliases. From users U or max, o.order_date, latest_order_date works just fine. I always use these aliases in a select statement right after the from clause. I also make sure every alias is on a new line, so I can find them easily. It is just a habit, as it makes the query more predictable and easier to read. Just a little note. When using users as U in a SQL query, we assign the alias U to the users table. From this point onward, the original table name users can no longer be referenced in the query. Instead, you must use the letter U whenever selecting columns or applying conditions related to this table. And another note. The word as is optional in some database systems or must be left out at all. Check the documentation, or simply try it first with a small select statement. If you can use it, use it. The next item in our query is join. Join orders as O on u.id equals o.user_id. In SQL, a join is a way to bring together information from two or more tables based on something they have in common, like a shared column. Imagine you have got one table with customer details and another with their orders. On their own, they are just separate lists. A join lets you connect the dots, so you can see, for example, which customer placed which order, all in one result. A join combines rows from these tables whenever the values in the specified columns match up. In our example, we linked users to orders using a user ID, and then orders to products using a product ID. It is like building a bridge between tables, letting you pull out a bigger picture, like who bought what and when, without having to manually stitch it together. At its core, a join is about relationships. Databases are often split into multiple tables to keep things organized and efficient, but real-world questions, like which users ordered electronics, need data from more than one place. A join makes that happen, uniting the tables into a single, useful output. It is a fundamental tool for exploring how your data connects, and it is what powers so many practical queries. An example. Join orders as O on u.id equals o.user_id ties each user to their orders. Join products as P on O.product underscore ID equals P.ID links those orders to the product spot. Filtering data with where U.country equals USA. And P.category equals electronics. And O.order underscore date between January 1, 2023 and December 31, 2023. Where filters results based on specific conditions. The user is in the USA. The product category is electronics. The order date is within 2023. The where clause is crucial because it determines which rows are included in the result set. Instead of retrieving all data, it filters records based on specific conditions. In this case, we are applying 3 filters. The user must be in the USA. The product must belong to the electronics category. The order must have been placed between January 1, 2023, and December 31, 2023. Without the where clause, the query would return every record from the database, including irrelevant data. In large data sets, this could lead to performance issues and make it harder to extract meaningful insights. By using where, we refine our results, making the query more efficient and focused. So, the where clause in SQL is like a gatekeeper for your data. It decides what makes the cut and what stays out. When you are pulling information from tables, you usually do not want everything, you want specific stuff that matches certain conditions. That is where comes in. It filters the rows based on rules you set, like only show users from the USA or only include orders from 2023. In our example, it narrows down the crowd by checking the country, category, and order underscore date columns, ensuring we only get the rows we need. Think of it as a spotlight, it shines on just the data you care about, leaving the rest in the dark. Without where, you are stuck sifting through a giant pile of results, but with it, you get exactly what you need, clean and simple. Between January 1, 2023 and December 31, 2023. Specifies a range for the order underscore date, including the boundaries. Like greater than or equals January 1, 2023 and less than and equals December 31, 2023. In SQL, between is a handy filter that zeroes in on a specific time window. It is like telling the database, only grab orders that happened in 2023. Paired with the rest of the where clause, it narrows your data to just the rows you want, in this case, orders placed between January 1 and December 31 of that year. The between clause specifies a date range for the order underscore date field, including both the start and end dates, and everything in between. This is equivalent to writing, order underscore date greater than or equals January 1, 2023 and order underscore date less than or equals December 31, 2023. Using between makes the query more readable and ensures that we capture all orders within the specified time frame, including those placed exactly on January 1 and December 31. Group by U.ID. Then, Group by U.ID takes over, acting like a filing system. It sorts those filtered orders into stacks, one for each user, based on their user underscore ID. Together, they set the stage, between picks the right time frame, and group by organizes the results by user, so you can summarize things like how many electronics each person bought or their latest order date. It is a 1-2 punch, filter first, then group up the leftovers into something useful. Filtering groups with having. Having count, P.product underscore name, greater than 2. The having count, P.product underscore name, greater than 2 line in SQL is like a bouncer for your group data. It checks the groups you made with group by and only lets the VIPs through. While where filters individual rows before grouping, having steps in afterward to judge the groups themselves. Here, count, P.product underscore name, tallies up how many electronics orders each user has, and the greater than 2 part says, only keep users who bought more than 2 electronics items. It is a way to sift through your summaries and focus on the heavy hitters, like finding the users who are really into their gadgets. Without having, you see every group, even the ones with just 1 or 2 orders, but this keeps your results sharp and meaningful. Order by latest _order _ date descending. The order by latest order _ date descending line is like arranging your results on a timeline. It sorts everything based on the latest order _ date column, which we defined earlier as the most recent order date per user. The desk part means descending, so it starts with the newest dates at the top and works backward to older ones. Think of it as putting your most active or recent buyers front and center, so you can quickly spot who has been shopping lately. It is all about presentation. Without order by, your results might come out in a random jumble, but this gives them a clear, logical flow that is easy to follow. Limit 10. Capping with limit. The limit 10 at the end is like setting a guest list cap. It tells SQL, just give me the top 10 rows, please. After filtering with where, grouping with group by, refining with having, and sorting with order by, you might still have a long list of users who fit the bill. Limit trims it down to a manageable size, showing only the first 10 after all that sorting. In this case, you get the 10 users with the most recent electronics orders who bought more than twice in 2023. It is perfect for when you want a quick snapshot instead of a flood of data. Think of it as the highlight reel of your query. Select distinct. Let us take a look at the following example. Select distinct user.id as user_id, order.order_date, product.product_name. Select distinct removes duplicate rows. In this case it guarantees that each combination of user, order, and product is unique. In this example we use the distinct keyword to ensure that there are no duplicate rows in the result. This is particularly important when joining multiple tables, as the combinations of data might cause repeated rows. Using distinct guarantees that we get unique combinations of user, order, and product. The column alias user_id instead of just ID makes the output more readable. Aliases are essentially temporary names, and they are very helpful in making the output more understandable. This is especially the case where the database designer may have chosen long or confusing column names. You can create aliases with the as keyword, which helps make the query more self-explanatory. Get used to using the keyword as and write readable queries. Let's go back to order by. Order by order.order_date descending, product.price ascending. Order by sorts by order_date in descending order, most recent first, and by price in ascending order, cheapest first. The order by clause allows us to sort the results in a specific order. Here, we are sorting by order_date in descending order, so the most recent orders appear first. Within each date, we are further sorting by price in ascending order, ensuring that the cheapest products are listed at the top. This kind of sorting is particularly useful when prioritizing recent transactions while also considering price comparisons. Formatting. Select distinct user.id as user_id, order.order_date, product.product_name from users as u. SQL keywords like select, distinct, from, and as are written in uppercase to improve readability and differentiate them from column or table names. Keep table names short and the same size. Short names minimize typing and streamline queries. Clear and short names reduce visual clutter in complex queries. Consistent naming conventions make it easier for others to understand and maintain your SQL code. It is a good practice to write SQL keywords in uppercase. This improves readability and makes it easier to distinguish keywords like select, from, distinct, and as from column and table names. While SQL itself is case insensitive, following this convention makes your queries clearer, especially when working in teams or reviewing code later. Just give it a try, write a query the way I suggested, and the same query with all uppercase or all lowercase letters. In addition to formatting, using short and consistent table names helps reduce typing effort and minimizes visual clutter. When table names are concise yet meaningful, your queries become more readable and manageable. For example, instead of a long name like customer_order_history, you might use orders. Keep it short and meaningful. Similarly, column names should be clear and descriptive. While database designers sometimes use unclear or cryptic names, you can improve readability by using aliases, to assign better names in your queries. This makes it easier to understand the output at a glance. By following these best practices, uppercase keywords, short and consistent table names, and clear column aliases, you create SQL queries that are easier to read, maintain, and debug. Over time, these small habits contribute to writing clean, professional, and efficient SQL code. Use comments. This is a single-line comment. Select asterisk from table, works here too. /**. Multi-line comment to document complex queries or temporarily disable code. */. Use comments. Comments are essential in SQL, especially for documenting complex queries or explaining parts of the query. You can add single-line comments using -- and multi-line comments using / and end with */. This helps others understand your logic, and it also lets you temporarily disable parts of your code while testing. When working with SQL, you may return to a query weeks or months later, or share it with colleagues, so well-placed comments help clarify the logic behind your statements. As we have seen, SQL supports two types of comments. Single-line comments using -- or double sign. This is also called a single-line comment marker or just a comment symbol. These are useful for brief explanations or quickly disabling a single line of code. Multi-line comments using / and end with */. This is for multi-line comments and is called a comment delimiter. These are great for longer explanations, complex queries, or temporarily disabling multiple lines of code. Use comments. Yes, because many people do not. This one day will come for all of us. You start a query and you are halfway. Then you are busy with something else for 1 or 2 weeks. You return to your project later and you look at your code like, what am I doing here? So you start all over again, getting to the exact same result. So use comments. That wraps up this video on Select, the basics. In the next video, we will look at the logical query processing order. I look forward to seeing you there.